Alrighty. We got a helicopter flying overhead. Go away, helicopter. Choo! Choo! It's literally a helicopter. Anyway, we got 2 tasks, and bummer, I gotta plug my VCR in before I can do it. You know, I'll plug it in after I open it so that I can make sure it's safe. Anyway, so before we crack open this VCR, and this one is my secondary VCR. This is my Sharp VCR. See, it says Sharp. Same company that builds the Sidekick, or the original Sidekick. In fact, the last Sidekick device was manufactured by Samsung, and it was an Android device. But that is off topic. Right now, we are working on a VCR right after we go over my electronics haul, and I want to give a holler to the Super Mario Brothers movie fan channel. We got them in the chat right now, and I'm looking up because my YouTube chat is on my second monitor right now, and we're gonna just pop in a link for that channel so that y'all can you young men and ladies and gentlemen can all check out his content. And of course, like any other channel, you got the tabs and you got the videos and live stream sections. So, you know, check those both out. But he's definitely doing a lot of live streams lately when it comes to games, gameplay. Yo, speaking of VHSs of the Mario movie, I have a stack of Volume 1. I don't know what season, but it says Volume 1 Super Mario Brothers Super Show. I think it's a 4-disc. Yeah, it's like a box set, but I think it's 4 discs, maybe more. It might be 4 jewel cases inside a box. And I bought it years ago when I was working at the Best Buy because, you know, I mean, I remember the show as a kid, and at that point in my life, it was like a vague memory that there was this weird TV show, not that it was terribly weird, where it was literally a Super Mario Brothers cartoon, and it would go back and forth between, you know, the live action and the cartoon, the animation. It was a real fun show. It was, you know, I loved it. And I just have these memories of being like, you know, like I'm talking like 1992, 5 years old, whatever I was. TV back then was in the corner of the living room, also manufactured by Sharp. It was one of those wooden TV sets, you know, where you have the wood and then you got like the felt in front of the speaker grill on the bottom, big old CRT, not humongous, but, you know, it was a moderately light TV. It was like about, I think, yay big, you know, so it wasn't quite 32 inches, it was smaller, but it wasn't tiny either. It was a decent color TV, and yeah, we would watch that in the afternoon, and like the first episode of the Super Mario Brothers Super Show that I can remember is the one when they go to Boxland, and they get into a car, and the car has square or almost cube-shaped wheels, and it just looks so absurd. The car's driving and cube-shaped wheels, like boom, 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 you know. But anyway, so I got this bag of goodies here that I got on Amazon, and man, lighting is a little bit sketchy right now. Let me see if we can fix that lighting situation there, because it could be like the way the lighting is. I think I put my camera into manual mode yesterday. I think that's what happened, because it was something I did required it. So we could easily rectify that by hitting apply. There we go. Already an improvement. So what do we have here? Well, let's take a look here. And great, now there's a helicopter hovering. I thought the helicopter was just gonna pass by. Nah, that stupid thing is hovering. So, number one item I got is this thing here called a Manayo. DM3 Manayo. And I mean, I think it's a Chinese brand, but it sounds Japanese to me, you know, like Mr. Manayo. And basically, it's an inline amplifier or preamplifier for a microphone. So when I was testing out the Samsung Q9U, was it? Yeah, this is the Samsung Q9U. As you can see, it says, literally says Samsung Q9U microphone there. Let's get that dirty tissue off my desk. I would plug into a speaker, you know, this device here, which is like an XLR to USB sound interface. And, gosh darn it, man, this helicopter. There, I'll close my window. It's like literally hovering now. I locked my window to try to keep the sound out. So, basically, you know, you got your XLR microphone. It's USB and XLR. You know, we have a USB Type-C port over here. And the problem I was having was when I hooked it up to this computer up here, I felt like I couldn't get it loud enough. Like literally I was going to join a stream. Anti-Derivative Jill was doing a stream about like, you know, science fiction technologies that may exist in real life. And I wanted to pop into there and talk about the Casimir effect and show some, you know, web pages, wiki articles. Basically, the Casimir effect is when you take these two metal plates at an almost nanoscale, you know, like microscopic nanoscale, and you put them real close together, but you fix them like in a way that they can't move. Like there's no way the metal plates are moving at all. But yet when you put when you create a magnetic field between these plates, they're able to, scientists working on the experiment can measure a reduction in distance so that the metal plates, instead of being like, you know, let's say 5 nanometers apart, they're like, I don't know, 3 nanometers apart or something like that. It might even be a fraction of a nanometer. But the bottom line is they're able to see that when they make a magnetic field, the distance between the two plates gets reduced. And yet, there's no movement. Like, they are certain there's no movement whatsoever. Like, you know, everything is like, you know, solidly mounted. And this is sort of like a little example of like potential candidate for what can be used to do warp drive or some superluminal faster than light travel at some point. And it's really just very basic foundational. But my point is I wanted to bring this up and share this information, and I couldn't, because this microphone here just wasn't loud enough. Like, I put the interface at max or near max and on the input, and it was just not satisfactory. So because I, you know, like that particular day, because this microphone was not as loud as the other people on the stream, and I wasn't able to join in a timely manner, because then I had to spend an extra like 10-20 minutes plugging in my current microphone, plugging it back in, making sure it's set up right. And I went back from this to this again, right? So the solution to that issue was a preamp, or at least one of these solutions is a preamp. So going over USB Type-C, it worked, but I just couldn't get it as loud as I wanted to get it. Over the interface, same issue. It worked just about as well. Honestly, like, I think it works really great over USB Type-C, but XLR has certain advantages we'll get into in a moment. But to get it any louder or to amplify the sound coming through here, I would have needed this. So bottom line, that's why I bought the Manayo DM3 preamplifier. That's what we're looking at right over here. And just like I said, you got USB Type-C, you have XLR interface over here. Many people like XLR for a multitude of reasons, and the main thing I can see about XLR is you could run a really long cord, whereas USB could theoretically, you know, run 15 feet or more, but it gets a little dicey. You don't usually get interference or signal issues on USB. You will either have an all or nothing signal. So I have a friend who was having some audio issues, and I don't think it was the USB ports per se, although it started to sound like there was some kind of shorting. In fact, I think what was happening was it started making sense. So in their case, their audio would cut out and their software would automatically switch from their primary microphone to a headset. And so you'd hear this ugly static sound. Now, once I understood if that's why it was happening, it made sense. Or why the sound was coming up on the line. But the initial cause at the time, I thought the static noise, when I first heard about it, was coming from, you know, the microphone itself. And so I was under the misimpression that, well, that's impossible. USB can't create interference over a long run or a bad connection. But once I understood it was because the USB connection was, you know, temporarily shorting out and switching over to another headset microphone or a different microphone. Okay, cool, makes sense. What's my point? My point is, assuming that being the issue, well, then it makes sense. The USB ports can have a short, so if your USB cables are too long, if there's not enough power, if there's a power deficit on USB, and that's something I should record a different video on, but that can cause issues. So bottom line, I'm circling back like Jen Psaki. The device I picked up online is called the Manayo DM3, as you can see right here. And it is an inline preamplifier for XLR microphones. I bought it for my Samsung Q9U because I couldn't get it to be loud enough. Like when I wanted to pop into a anti-derivative Jill live stream, that's the name of the channel, I couldn't because I had to switch from this to this microphone, and it took me too long. By the time I did it, the stream was already coming to an end. And just for whatever reason, I couldn't get the audio to be loud enough. Like, it sounded fine, but I felt like it just wasn't as loud as everybody else, no matter what I did. You know, I kept recording and playing it back and comparing it, and it just wasn't loud enough. And so this preamplifier, a inline preamp, can be plugged in probably one of two places. But in this case, I would plug it into the back of the microphone like that. See? And then you'd plug your XLR cable into here, and the other end into your interface, and that should do the trick. So we're going to check that out. We're going to test that out in a little while. I may or may not do that in a separate stream. So that's number one. What else do I have in the bag here? Well, this is cool. I got cool things here. All right, so this is a 1 terabyte solid state drive. Why do I have a solid state drive? Why do I have a new solid state drive, and why did I choose this brand? Well, I chose a, let's talk about the type of SSD. This is a 2.5-inch SSD, which is, you know, same size as a standard laptop hard drive. You know, see, got some like laptop hard drives here. They all have, you know, 2.5-inch form factor. This is serial ATA. This is IDE or parallel ATA. I could theoretically get an adapter and put this type into an original Xbox. And I also have a modern adapter that allows me to put a serial ATA hard drive into an original Xbox. And so my goal here is to have a drive that is silent. And also during the summertime, it will not emit a lot of heat. But this drive will be completely silent. It'll be solid state, so it's not going to be susceptible to shock or drops or vibration or anything like that. So it should be very sturdy and reliable. I will continue to maintain backups, so I have my modified Xbox, I have my games and things stored on here, but I will continue to run backups. In fact, I would run a backup script on my server so that on a regular interval, all I have to do is turn on my Xbox, and I could either schedule it automatically or issue a command that would fire up that script, and it was just basically FTP into the Xbox and download or synchronize any changes. And most likely we would have game saves, you know, game save data, progress in a game, and you know, it could be in both Xbox games and emulation. So I'm looking forward to putting this into a modified Xbox because it would just be real sweet. The other reason I chose this, the more important reason actually that I chose this, because I'm not really worried about noise, although it's nice. And, you know, thermal conditions, you know, it's nice to have any device running cool during the summer is nice because everything emits a lot of heat. I mean, this computer, when I play a game on the graphics board, it puts out a lot of heat. And this air conditioner, you know, is a good air conditioner, and it has to, you know, use a lot of energy to keep up. But the other reason is because this is slimmer, and I have too many hard drives up here to grab a, we'll do it anyway. All right, so not the best example because this happens to be a slimline 3.5-inch hard drive, 3.5-inch wide. But a normal 3.5-inch hard drive is a little bit thicker than this. And every Xbox will have a hard drive at least as thick as this one, if not thicker. And the issue with that being is, well, what if I want to make a small Xbox? So here's an interesting thing. I have, some of my Xboxes may have faulty DVD drives. So if I don't have a working DVD drive, I only need a working DVD drive in one Xbox, and technically I don't necessarily need an Xbox at all to have a DVD drive, but I want to have one Xbox with a DVD drive so that I can either rip game discs directly or, you know, whatever situation requires a DVD disc. Secondly, for the other Xboxes, they don't need DVD drives necessarily, or at least I'm going to have at least one Xbox that does not really have a DVD drive in it. And if I do something like I put an SSD and I take the DVD drive out of an Xbox, I can have an ultra slim Xbox. I'm really looking forward to like basically taking a saw, taking a Dremel rotary tool, and just slicing it down, you know. So you have the top and the bottom of the Xbox's chassis. What I want to do is I want to have a slim SSD right here. So just have a little itty bitty SSD up here. Have just a logic board, no DVD drive, just a circuit board plugged in here. Because I think you still need to have a DVD drive plugged in, but you don't actually have to have it like, you know, fully operational. So if you just have the logic board, you're good. So bottom line is that you have basically something very slim over here, something very slim over here. That means there's a lot of volume that is no longer needed. And so I'm thinking we could slice it up literally from here on down. So we could at least have an Xbox that is not much thicker than this area over here. And maybe even thinner. But of course we have to make sure we have to allow some airflow, right? We have 2 heat sinks in here. And basically both of these heat sinks rely on one fan. This fan pulls air out. In fact, that might be my limiting factor, is the measurements on the fan. Now, from what I can figure, actually the fan pretty much lines up with the dimensions that I've already illustrated. So I could do it, and honestly, I wouldn't even mind if the back of the Xbox was a little bit thicker. But I don't know, work it out. I think I can work it out. So I want to have a slightly slimmer Xbox, and if I really want to get adventurous down the line, we can find other ways to make it slim. You know, we can basically make, you know, put a different fan or put the fan in a different angle and put the SSDs as close to the motherboard as possible. And that should, you know, get it maybe even slimmer down to the controller ports, perhaps. You know, we get it down to that, you know, because I don't want to go and rebuild an entire design that already works. But I do want to make it slimmer, so I'm looking forward to doing that. So that is why I have a solid state drive over here. And why did I choose Corsair brand? Well, I should have mentioned that first. I chose the Corsair brand because they seem to have very good details on how they do their design. Like, what I mean is, every SSD has some NAND chips, which are like sort of like, you know, almost like flash memory, NAND chips, not, and, you know, it's like a whole logic gate type thing. And what is it called? Manager, like, there's basically a utility that Corsair puts out called the Corsair SSD Toolbox, and then there's another tool which I can't remember right now, but we're going to find out. So this is one type, but let's see if we can find it. Let's see here. So we need Corsair wear leveling. So basically, they even have an article here called over provisioning. Basically, a portion of the space on the SSD that is reserved for use only by the SSD controller. And what they mean by that is, if I have a 200 gigabyte or a 1 terabyte SSD, let's say I have a 1 terabyte, there's going to be like an extra 200 gigs of storage in there that I cannot access. And that's so that essentially, as you write to the terabyte of usable capacity, some of the cells are going to wear out. Some of the NAND cells or blocks are going to wear out, and you can't write to those blocks anymore if you write to them too many times. A good SSD has a controller, a chip that tells it to distribute it, to spread it out, so that instead of getting rug burn or wearing out the carpet in one area, you're spreading out the wear and tear over a wider area to prevent any cells from prematurely failing. But also, you allocate some extra square footage, so to speak, and when some of the tiles, let's say, on that floor start to wear out badly, you can grab some of those extra tiles in the closet over there and replace the bad tiles. So essentially, that's what we mean by over provisioning. It's actually including extra capacity that you cannot use, so that when some of the cells or blocks wear out and cannot be used anymore, the controller can reallocate those cells. It can disable the bad cell and replace it. Great. So now this helps this increase both longevity and performance, supposedly. Cool. However, some users would like to buy their SSDs without the overbuilt, you know, capacity, inbuilt over provisioning, which I think is kind of dumb. They prefer flexibility of deciding for themselves when to over provision and how much to use based on their needs. Okay, I guess that makes sense. Just don't blame the SSD manufacturer when your SSD fails early. And in fact, this picture kind of gives us an idea here. So when it's recording data, it's going to select a block that has the least, amount of usage or valid pages, least number of valid pages for garbage collection. After successful erasure, block goes to the free block pool. So next time it wants to write data, there's a block it can write to that free block, and then data goes onto the free block, goes over here, looks for a block that has, I guess, the least amount of data written to it so that it can erase it and allocate it again. But that's just one little facet to this. So bottom line, they have a series of SSDs that isn't using so much over provisioning, which I guess means that, it's going to fail sooner or give you better performance. And I mean, they do have these weird looking, heat sinks on some of them. Interestingly, the majority of the SSD doesn't really get hot. It's just the controller that gets warmer, from what I understand from touching them and measuring them myself. And I get some interesting advertisements here. Okay, so that's useless, that's useless. Now, what I'm looking for is a utility. There is a utility that lets you, actually adjust it. And I bookmarked it. I literally bookmarked it while I was at work the other day. So let's take a quick look at my notes and see if I can, try to find it. Oh, good. The helicopter stopped flying. It's starting to get hot in here, man, with the video encoding and all of that. Okay. I can't believe that I can't find the stupid application name anymore. Maybe it really is called the SSD toolbox, but I could almost swear it had a different name. So you've got LBA, Trim Smart, firmware updates. Yeah, I don't think this is what I'm looking for. Let's see, maybe we could go and drill it down. Now, interestingly, they have this program called the Corsair IQ utility, and it has never freaking worked for me. It's for controlling the stupid LEDs, and I'm about to completely uninstall it because it has not been... Do I have to sign into this? I'm not signing in right now. Yeah, okay, let's skip that. But I got to reinstall it, see if it works. But I tell you, it worked for a little bit, and it's just super sketchy with the way it hooks up to the USB bus. Also, I think there might be some conflict with the MSI software, although I'm not quite sure about that. It seemed to stop working reliably after I got a graphics card that had a LED on it. And you know what? I do have a Corsair SSD, so I can actually try it out on this computer. Good, we can run the installer straight out of the zip file. And I got a phone call that I missed, and I guess I should check my phone, but it's I don't really care. It's just I better check if it's important. And let's see where we go from here. Okay, so this is the Corsair SSD toolbox, and it knows that my first drive letter is an SSD. Minor version is not reported. Okay, I don't really, it's not important. It tells me the temperatures. Tells me that I've read and written a total of 13.2 and 13.9 terabytes to it. So basically, when you buy these SSDs, you can actually look up the total writable data. So this is a CT1000P5 SSD 8, and we can look at the official documentation. We can also look at probably the manufacturer's website. I mean, we can look at Amazon or the official website. So I have a 1 terabyte, and I want to see the specs on it, because somewhere here it should tell us not just the speed, which is all great and dandy. In fact, I want more information. See, I want to know the TBWs. I'm surprised that, leave it to the company to be all marketing oriented and not tell me the TBWs. Okay, so we can check Amazon or this, and here we go. It says it right here. This has a 600 terabyte TBW total, whatever. Basically, bottom line is that I have a 1 terabyte SSD, and I can write to it and rewrite to it 600 times. I can erase it in its entirety and then rewrite to it. And so right now, I've only done it 13 times. So I have, in theory, over 575 more times. I can still write another 575 terabytes to it, and I've only written 13 terabytes. And part of what makes this possible is the over provisioning. From the top, when it comes to an SSD such as a good brand name like Corsair, the reason I chose this Corsair SSD, even though I'm only going to use it in a modified Xbox, and so the amount of demand I'm going to put on this SSD isn't very high, but I wanted a quality SSD. Now, if you go and you do a Google search, you look up over provisioning or wear leveling, although Corsair calls it this. Basically, over provisioning is when it allocates extra blocks. And you know, it's funny, I just had a whole entire article on the screen here where it was all about that, and it's gone. Here it is. Is this it? Nah. Here we go. Perfect. And so bottom line is that you have so many blocks available in an SSD. If you write to an individual block too many times, it becomes unusable. And a good SSD with a good controller will, at the bare minimum, disable that block and allocate a less used block, or a block that's completely unused, like a reserve block, to replace the broken block. A better SSD, a better quality SSD will, of course, manage the leveling of the wear on each block. So you don't write to one group of blocks. So, if you have blocks at the beginning and at the end of your drive, usually you might only write to the beginning ones. And if I write some data here and then I delete some data, so let's say I have this many, let's say this is like 1, 2, 3, 4 gigabytes, and I delete a gigabyte of data. Now, when I want to write new data, it's going to write the gigabyte of data on the blank one, right? With wear leveling, instead, I'm going to write 1, 2, 3, 4 gigabytes. But even if I erase a gigabyte of data from here now, what it really should be doing is writing data over here, spreading it out, spreading the love, you know what I mean? Spreading the writes so that no one block gets over worn out. But if at any point an individual block does get worn out for any reason and cannot be used anymore, there will be blocks in reserve. So you'll have a 1 terabyte SSD, but you'll actually have an extra 200 gigs on reserve that are made available one at a time. So this block goes bad, it disables the bad block, and then it grabs another block from the reserve pool. And this diagram is not representing it. I'm just borrowing the diagram to point at blocks. And thus, your SSD will keep chugging along for longer. If, on the other hand, you don't have those reserve blocks, those over-provisioned blocks, your SSD can fail sooner. Now, how do we know, how much is allocated, how much over-provisioning is available? Well, wherever you buy an SSD, whether it be Amazon or somewhere else, you'll see a number here, 600 terabytes written. on a 1 terabyte SSD. So what that's saying is that on, this is the 2.5, but if we're looking at the SSD that's inside my computer right now, this is the exact SSD that's running this desktop right now, running the C drive on this desktop. I could write to it and rewrite to it 600 times total because it's 1 terabyte. So if I fill up the entire SSD and I erase the data on it and I write new data to it, it'll do that 600 times before completely wearing out. And according to the SSD toolbox, I've only done it 13.2 times. So, or I've read, actually reading doesn't matter. Reading is good to know. It's the writes that matter. So I've written nearly 14 terabytes of data to this SSD over the time I've owned it. That's the equivalent to writing to it and erasing it in its entirety and writing to it again 13 times, 14 times. And so I can still write to this 625 times more, over 625 times more. So 625 terabytes before this SSD goes kaput. If they decided to allocate less extra blocks or fewer extra blocks, then this number might say 200 terabytes written, 300 terabytes written, and that would reduce the amount of times I could do it, and so maybe now the SSD can last me 5 to 10 years of moderate use. Maybe lesser SSD would only last you 3 years of moderate use. Maybe this SSD will give me a good 5 years of heavy use and longer with moderate use, and that's kind of like what I'm looking for with the Xbox. Once I write to it, I don't expect to be rewriting to it very often. So this is definitely a little overkill when it comes to longevity, but I'm entirely fine with that because I figure let's over-engineer a retro game console because I want it to keep chugging along. I want it to be able to turn it on a decade from now and it just works, whereas with mechanical hard drives, they will probably just work. But if that thing, got kicked or dropped while I wasn't looking, because, people, they never drop their laptops ever. But somebody drops the laptop sooner or later when nobody's looking, and that's why laptop hard drives eventually fail for many people. Some people might take great care, but look, it just happens. You dropped a laptop, you don't even notice you kicked it hard enough. Maybe you kicked your laptop 20 times, nothing happened. It only takes one bad kick. Or somebody trips over the power cord when you're not looking, and that hard drive fails. And there's nothing wrong with using hard drives. I use them extensively, but in this case, yeah, in an Xbox, where the Xbox can be moved from room to room, where somebody's playing a game and they trip over the power cord and it falls down, or something like that, yeah, I want that redundancy. So what's the next item we got here? Well, if we keep going in my goodie bag, we got two cool things. Now, these two items here are more retro items. So for the two retro computing items that I bought, the first one is maybe a little ambiguous to some people, but this should make a lot of sense once you see it. So what we're looking at here is a SD card slot. In fact, let's open it up. And a parallel ATA connection. So basically, if I can just get this out. So I have many old computers from the 90s and even late 80s would have this type of connection for the hard drive, right? And let's make sure we can get this into focus. And so what you do is you put a micro SD or SD card in this slot over here. You plug this ribbon in, or this flex cable, and then you plug a power connection in here. And now, as far as my retro computer, my old computer is concerned, this is another hard drive. It doesn't really care. It doesn't know that it's an SD card. It doesn't really care. It sees a hard drive in there. And this is good because, you have really old computers with like 40 megabyte hard drives that, are really old. And you don't want to put too many, you don't want to put a ton of mileage on a really old hard drive that somehow by some miracle keeps working. The other thing is that my IBM PC AT actually has been upgraded numerous times. Like when I received that IBM PC AT, which is a computer from 1985, by the time I got it, it must have been upgraded in like 1991. And so it had a newer BIOS, it had a newer hard drive. So the hard drive was like not retro. It was like a 100 megabyte hard drive or 200 megabyte hard drive, not particularly retro. Might have even been 500 megabyte. But I eventually put a 1 gigabyte drive in there, which was a big deal at one point in time. But instead of having to work with like 1 and 2 and 4 gigabyte hard drives that are really old that will eventually fail, I could work with SD cards. Now, I would still back up the SD cards or have duplicate SSD cards that I can swap in and out if one of them wears out. But bottom line is it's super convenient. And people use these adapters on a variety of retro computing applications, like on the earlier computers, the pre-IBM PC era, when you have the Altair 8080 or the MSI 8080. The computer from, what is it, War Games? The one with the kid and the old computer, you know, the one with the kid who hacks the freaking military, like, you know, when a kid hacks the Pentagon or some crap. I want to say it's called War Games, but I don't even know. What is that called? Movie War Games. I think it's called, yeah, War Games. I'm pretty sure. Let me see here if I, oh yeah, that looks like, oh yeah, that's it. So, for example, this is an IMS Associates Inc. 8080. It's sort of an Altair clone. You can use these switches to like do mathematics and, you know, basic coding on the front panel. But typically you would hook it up to a terminal, something like this. And a terminal is designed to almost emulate a teletype machine, a telex machine. You can hook a telex machine up to it, which is like electronic typewriter with a modem or null modem cable. And essentially, using similar methods, you're directly, you know, typing into a COM port, and then the COM port is sending signals back out to your printer or your screen. And that's how you would have operated a computer. And you can run, you know, issue commands back and forth with the BIOS or a basic, you know, programming interpreter. You can, you know, put an operating system on there, and instead of getting a video display like a conventional video monitor, you're going to get your video display on a console, on something that, as far as the computer is concerned, is a sheer text device. And so, yeah, you know, when you're working with this, if you want to put high capacity storage, maybe you don't want to mess around with a 10-inch floppy disk system like this. Maybe you don't have one available, you can't get your hands on it, or you don't have the skill or time to repair that. Well, at that point, and especially when you start moving into hard drives, you don't want to mess around with a 10-inch Winchester, as they call it. You know, like, I think it was like, sorry, 8080 Winchester. And assuming that Google will be forthcoming, we should see a hard drive of some kind. Maybe, maybe not. I don't even know if they had hard drives for these back then. I mean, you could put anything on anything back then. Well, bottom line, this would have been the high capacity storage of that era. And if you get a hard drive that works with it, you're going to need like a bulky controller card and a drive and all of these other things. And sometimes it's just less of a hassle to have this, especially when you have to, you know, you can't restore hard drives as easily. So yeah, bottom line is I'm very excited about this. I spent a lot of time on that. Let's move on. Now, the next item I got was this floppy disk emulator. And this thing is super cool right here. So it's got the same connection as a standard 20-pin floppy disk drive. Same power connection. And it has some jumpers on here. And it has a USB port on it and some numbers on a front panel. So what does this actually do? Well, basically, you plug a USB flash drive in here that's been formatted ahead of time. And if you have some floppy disk images on here, you could have like probably more than 100 of them. It's just literally like a 1 or 2 megabyte file that's, you know, .img. You know, a .img file. And one of them might be the MS-DOS installation disks. Disk 1, Disk 2, Disk 3, Disk 6, depending on the version of DOS. Maybe you have some games on there. Once again, you have the floppy disk image files, because when you download a floppy disk image from an archive website, it's going to be a disk image. It's not going to be, you know, it might be a you know, old disk image, and you got to mount it. And then if you want to put it on your old computer, you got to mount the floppy disk image and copy it to a real floppy disk drive, which means you got to hook a floppy disk drive up to a modern computer. And there's a number of reasons why that could be tricky. Basically, like my last computer that came with a floppy disk drive was a Dell Dimension 8200. Fine machine, but the problem was all of the dust, all of the airflow, the way the fan was configured, all of the airflow was coming into the floppy disk bay. And so eventually that floppy drive wasn't going to work. After years and years of not being used, it wasn't going to suddenly work, you know, when you put a disk in there. Even if you cleaned it, it may not work. And so a lot of floppy drives just never even got a chance to be used and wore out from airflow and dust alone. And then even if I get one working, it's kind of tenuous because now I need a floppy drive to work in my, you know, regular computer, my modern computer, and my retro computer, which tends to work out better for me because a lot of times the older floppy drives seem to be built more solidly. But now you got to still be jockeying disks around. You know, you got to write data to a floppy disk and then bring it upstairs to downstairs or computer to computer if they're side by side. Now, the best floppy drives in this day and age, if you need a floppy drive, the ideal floppy drive would be an external USB floppy drive because, I mean, they're completely sealed and enclosed. You're not going to get any dust into there. They're not going to wear out prematurely, and they seem to be pretty reliable and fast. But even those are kind of hard to get a good price on it nowadays, you know? But this here is just easier to work with. Now, I still intend on keeping a floppy drive installed in my IBM PC-18. I got to figure out how to configure it physically so that I can have a 5 1/4, a 3.5 inch, and an emulated floppy drive. I'm sure it's possible. In the immediate short term, I'll probably just take out the 3.5 inch floppy drive and put this in its place. In the longer term, I'm going to 3D print some kind of bay or bezel so that I can put this directly on top of or directly beneath the normal floppy drive so that I can easily, you know, take a real floppy disk, put it in, and copy the floppy disk into a disk image. In fact, that would be kind of cool to have some blank disk images on here and to be able to use this to assist in archiving, to use a 35-year-old computer to assist in the task of archiving floppy disks that I have laying around, because the ideal goal is to get all of those floppy disks into disk images so that the floppy disks could be kept in a sealed box for safe keeping, safe storage for, you know, the long haul, but to have the data from those floppy disks stored in multiple places, have them stored on a flash drive, you know, so that the floppy disk emulator can switch between those disk images. But also have those floppy disks backed up to my server. Back them up to the cloud if you want, you know, but like back them up every which way. Upload them to archive.org. If, let's say, somebody hasn't uploaded a specific disk already, why not? And so, yeah, the two key things for my retro computing restoration efforts are indeed this floppy disk emulator and this SD card slot for the hard drive, the IDE to SD card adapter. So we have the IDE ribbon connection here. We have the SD card slot here. This will allow us to emulate a hard drive inside a 35-year-old IBM PC-18. And so, you know, depending on how this works, if I could partition it and select different drive letters, great. If not, I don't really care. If I could just run one operating system, I can create boot disks that tell it to boot up off of each partition. So there's different ways to manage that. If I can't set up a bootloader, or if a bootloader is a pain in the butt, I'm pretty sure we can use boot disks to tell it what partition to boot off of, and setting up an MBR, you know, bootloader should be simpler than a modern one. And then, you know, you just have these buttons up, down. So it's like I just have to literally keep a print out, most likely, saying what each disk is. Because like it'll be like number 1 will be, let's say, you know, normal boot disk. Number 2 will be the MS-DOS installer. Number 5 will be the Windows 3.1 installation. So that's a little weird. You know, it'd be nice if these had actual labels, like file names on them. You know, that would be the coolest thing. If you could give each floppy disk image a file name and have that file name come up on the little display on the front, that would be pretty sweet. But the fact of the matter is, the main priority is to make something like this cheap, to make it affordable. And that it is. It is definitely an affordable. I didn't pay a whole lot of money for this, so I'm a happy camper with this. And then for the remainder, I think I have some screws here. Yeah, I got some screws here, so we should put the screws in the box. put this little instruction manual packet in here too. And these two are going into my IBM PC-AT. You can also use these in other devices. So for example, like let's say you have a Yamaha keyboard. You know, like one of those MIDI keyboards where you can save your musical notes onto a floppy disk. Then the floppy disk emulator would be, you know, something you would want to put inside that, you know, for a multitude of reasons. The fact that you can interoperate USB, and you could go from the modern computer to the, you know, Yamaha keyboard with a USB flash drive, as opposed to having to figure out how to get a floppy disk, you know, into your modern PC. That is a fantastic godsend. So yeah, that covers the retro computing haul. Now I'm going to stop this stream, and we're going to fire up a microphone test. So with that, thank you for watching. Please like and subscribe. If you have any questions, comments, or ideas, please leave a comment. And for now, we shall end